Under Adolf Hitler, the Nazi Party believed it had rebuilt Germany faster than history should have allowed. The army looked modern. The strategy looked bold. The men inside the machines believed they were ready. Early victories reinforced that belief, turning confidence into certainty. But when battles grew harder and enemies adapted, the cracks began to show. Not in courage, but in decisions made years earlier. Each failure pushed Germany to build something stronger. Each success convinced them they were on the right path. And without realizing it, they began designing tanks not for the war as it was, but for the war they wanted to fight. Panzer I, 1934, two-man training tank. The world was watching Germany in 1934. Treaties were still fresh. Restrictions were clear. Any wrong move could bring consequences nobody wanted. But armies do not rebuild themselves overnight, and Germany knew it needed to start somewhere. So they built something small, something that barely qualified as a threat. The Panzer I rolled out not as a weapon of conquest, but as a moving classroom. 2 machine guns, thin armor that could barely stop rifle rounds, a crew of 2 learning how metal behaves when it moves across uneven ground. Training was the entire purpose. Crews needed to understand coordination, how a driver's decision affects a gunner's aim, how radio communication could turn chaos into strategy. Tank warfare was not just about building better machines. It required men who understood timing, positioning, and when to push forward or fall back. The Panzer I taught all of this without pretending to be anything more. It was honest about its limitations, which made it effective at what it actually needed to do. Then, 1939 arrived faster than anyone planned. Poland needed to be dealt with quickly, and suddenly, every available vehicle mattered. Panzer I crews found themselves in real combat, facing actual enemies who were shooting back with intent to kill. Machine guns that worked perfectly fine against training targets now felt inadequate against fortified positions. Armor designed to protect against shrapnel could not handle anti-tank rifles. The tank that was never supposed to fight was now being asked to lead. Losses mounted. Crews discovered that bravery and training could not compensate for a design that was never meant for this. Some units succeeded through speed and surprise, overwhelming defenders before they could organize proper resistance. Others were not so fortunate. The Panzer I forced a brutal lesson on everyone involved. Preparation and readiness are not the same thing. You can train endlessly, perfect every maneuver, understand every principle of armored warfare, and still be fundamentally unprepared when the variables change. What made it worse was knowing this outcome was predictable. The Panzer I was always supposed to be replaced before any real fighting began. It was a stopgap, a temporary measure while better designs were finalized. But war does not wait for production schedules. It does not pause while engineers refine blueprints or factories retool assembly lines. The gap between what was planned and what was available became a problem measured in lives rather than spreadsheets. Still, the Panzer I accomplished something crucial. It taught an entire generation of tank crews how to fight as a coordinated unit. Those lessons, learned in a vehicle that could barely protect them, would carry forward into better machines. The crews who survived knew what worked and what did not, understood the difference between theory and application. They became the foundation for everything that followed, even if the tank itself was rapidly becoming obsolete. But surviving those early battles created a dangerous kind of confidence. If they could win with something this inadequate, what could they accomplish with proper equipment? That question was about to be answered, and the answer would reshape how Germany approached armored warfare entirely. Panzer II, 1936. Germany didn't waste time wondering what went wrong. They already knew the Panzer I was insufficient before it ever saw combat. The question wasn't whether they needed something better, but how quickly they could produce it. The Panzer II emerged as the answer, not perfect, but available. It carried a 20mm cannon instead of just machine guns, which meant it could actually threaten other armored vehicles instead of merely pestering them. The armor was slightly thicker, enough to provide a psychological edge, even if it couldn't guarantee survival. Speed became the defining characteristic. The Panzer II could move faster than most opponents expected, arriving at positions before defenses were properly established. Early campaigns in Poland and France demonstrated what velocity and coordination could accomplish. Tank columns didn't engage in prolonged duels. They bypassed strong points, cut supply lines, and created confusion deep behind enemy positions. The Panzer II wasn't winning through superior firepower. It was winning because it refused to fight the kind of battle it would lose. This approach worked brilliantly until it didn't. French tanks carried heavier armor and bigger guns. British Matildas could shrug off 20mm rounds without concern. When forced into direct confrontation, Panzer II crews had to rely on tactics rather than technology. They aimed for tracks to immobilize targets, then maneuvered for side shots where armor was weaker. It was effective, but exhausting, requiring constant movement and split-second decisions. One mistake meant the engagement ended badly. The Eastern Front revealed just how limited the design really was. Soviet T-34s appeared with sloped armor that deflected shots the Panzer II crew thought would connect. The 20mm cannon that worked adequately in France was completely inadequate here. Crews found themselves in situations where they could identify targets, maneuver into position, fire accurately, and still accomplish nothing. The rounds simply bounced off. Retreat became the only rational option, but retreat meant ceding ground and initiative. Production continued anyway because Germany needed numbers. Factories could build Panzer IIs faster than more advanced designs, and an imperfect tank in the field was more useful than a perfect one still on the drawing board. Commanders knew what they were sending crews into, but the alternative was having no tanks at all. So the Panzer II kept rolling off assembly lines, kept being shipped to units that needed reinforcements, kept fighting battles it was increasingly unqualified for. What's often overlooked is how much early success masked these fundamental problems. When Germany was advancing, when momentum was on their side, the Panzer II's limitations seemed manageable. Speed and aggression compensated for firepower, but momentum doesn't last forever. Eventually, every army encounters resistance that can't be bypassed, enemies that won't break, terrain that slows everything down. The Panzer II's early victories created expectations it couldn't maintain, and by the time that became obvious, the strategic situation had already shifted. Still, it bought time. Time for factories to retool, time for newer designs to reach production, time for tactical doctrines to evolve based on real combat experience rather than theoretical planning. The Panzer II was never supposed to win the war. It was supposed to keep Germany in the fight long enough for something better to arrive. And something better was already being tested, refined, and prepared for the challenges that were only beginning to reveal themselves. Panzer III, 1937. For the first time, Germany designed a tank specifically to fight other tanks. Not to support infantry, not to train crews, not to exploit breakthroughs. The Panzer III existed to win duels against armored opponents, and that single purpose drove every decision in its development. The initial design carried a 37mm gun, adequate against the light tanks most nations fielded in the late 1930s. The armor provided reasonable protection without sacrificing too much mobility. 3 crew members in the turret meant the commander could focus on tactics instead of also trying to load or aim. Then the war actually started, and reality immediately complicated the plan. The 37mm gun worked fine against Polish tanks, but struggled against French armor. British Matildas were nearly immune to it from most angles. German commanders sent urgent requests back to factories. Bigger gun, thicker armor, do it quickly. Engineers responded with a 50mm gun that offered significantly better performance. Existing Panzer IIIs were retrofitted when possible. New production incorporated the changes from the start. But upgrading one component creates ripples throughout the entire design. A heavier gun needs a stronger turret ring. More armor adds weight that stresses the suspension. The engine that provided adequate power before is now working harder, running hotter, requiring more maintenance. Crews noticed the changes immediately. The tank felt different, responded differently, and broke down in different ways. What worked in 1939 needed adjustment by 1940, and those adjustments created their own complications. The Eastern Front made everything worse. Soviet T-34s appeared with armor thick enough and sloped enough that even the 50mm gun struggled. German crews had to get too close to guarantee penetration. Combat ranges that should have favored the Panzer III instead became uncomfortably intimate affairs where both sides were trading shots at distances that gave minimal margin for error. Losses increased not because crews were making mistakes, but because the vehicle itself was reaching the limits of what could be upgraded within its existing framework. Field modifications became common. Crews added extra armor plates wherever they could attach them, knowing it slowed the tank, but improved their chances of surviving the next engagement. Tracks were widened to handle soft ground better, especially the mud that turned Russian roads into impassable morasses every spring and fall. These changes were not planned by designers sitting safely behind desks. They emerged from frontline experience, from crews who understood what they needed to stay alive. Production continued through 1943, not because the Panzer III was the best available option, but because factories were already set up for it, and newer designs were not ready yet. Nearly 6,000 were built in total, far more than any other German tank at that point. That volume meant spare parts remained available, mechanics understood how to fix common problems, and crews did not need extensive retraining when they received a replacement vehicle. Familiarity had value even as effectiveness declined. What the Panzer III proved was that good enough could be stretched surprisingly far with constant adjustment. Each upgrade bought a few more months of relevance. Each modification addressed one more tactical problem. But there is a limit to how much any design can evolve before you are essentially building a different tank while pretending it is the same one. The Panzer III was approaching that limit, and everyone involved knew the next step required something more fundamental than another incremental improvement. Panzer IV, 1939. Nobody expected the Panzer IV to become the tank that carried Germany through the entire war. It was designed with a completely different role in mind, supporting infantry with a short-barreled 75mm gun that fired high explosive shells. The goal was destroying fortifications, clearing buildings, and suppressing enemy positions so that troops could advance safely. Tank versus tank combat was supposed to be someone else's problem. The Panzer III would handle that. The Panzer IV would do everything else. War has a way of ignoring job descriptions. As German forces pushed deeper into France and then Russia, the Panzer IV kept encountering situations where it needed to fight other tanks, whether that was the plan or not. The short 75mm gun could damage enemy armor at close range, but close range meant exposing yourself to return fire, and the Panzer IV's armor was not designed for sustained combat against dedicated anti-tank weapons. Crews improvised, used high explosive shells to disable tracks or damage vision ports, but everyone knew this was a temporary solution to a growing problem. The decision to mount a long-barreled 75mm gun changed everything. Suddenly, the Panzer IV could engage targets at proper combat ranges. It could penetrate the frontal armor of most Allied tanks. It went from being a support vehicle that occasionally fought armor to being the primary tank destroyer in many German formations. This transformation happened not through careful planning, but through desperate necessity, because the alternatives were either insufficient or not available in adequate numbers. What made this possible was something the original designers probably did not fully appreciate. The turret ring was large enough to accommodate the heavier gun. Most tanks cannot be upgraded beyond their initial specifications without a complete redesign. The internal dimensions lock you into certain parameters, but the Panzer IV had room to work with, space that allowed engineers to mount bigger weapons and add more armor without compromising the basic functionality. That flexibility turned out to be more valuable than any specific feature the tank carried when it first entered production. Production numbers tell the story clearly. Germany built over 8,000 Panzer IVs between 1939 and 1945, more than any other tank model. Even as supposedly superior designs like the Panther entered service, factories kept producing Panzer IVs because they were reliable, mechanics knew how to fix them, and crews trusted them. The learning curve for new crews was manageable. Spare parts were abundant. Supply chains were established. Sometimes consistency matters more than excellence, especially when you are fighting on multiple fronts simultaneously. Combat reports show the Panzer IV succeeding in situations where newer tanks failed. Panthers might have better armor and more powerful guns, but they also broke down more frequently and required specialized maintenance. Tigers were devastating when they worked, but consumed resources at unsustainable rates. The Panzer IV just kept showing up, kept fighting, and kept doing the unglamorous work that actually determined whether battles were won or lost. It was not exciting, but it was effective. By 1944, the Panzer IV was clearly outmatched by the latest Allied designs. American Shermans appeared in overwhelming numbers. Soviet T-34-85 tanks had better guns and comparable armor. Yet the Panzer IV remained in production until the war ended because there was no realistic alternative. Newer designs could not be produced quickly enough to replace it. The infrastructure existed to keep building Panzer IVs, and stopping that production meant fewer tanks overall, which meant weaker defensive positions, and which meant losing ground even faster. What is remarkable is not that the Panzer IV eventually became obsolete. Every tank does. What's remarkable is how long it remained relevant, despite never being the best at anything. It succeeded through adaptability, through being good enough in enough situations that it could stay in the fight, even as the nature of that fight changed dramatically. And while attention focused on more dramatic vehicles, the Panzer IV quietly demonstrated that wars are won with tools that work consistently, rather than innovations that dazzle briefly. Panzer 35T. In 1939, Germany absorbed Czechoslovakia and immediately gained access to an entire industrial complex that knew how to build tanks. The Czechs had been producing their own designs, and the LTVZ-35 was already in service with their military. Rather than waste time developing something new or retooling factories for German specifications, the decision was made to simply keep production going. They renamed it Panzer 35T, the T indicating its Czech origin, and pressed it into service as quickly as possible. This immediate access mattered. The design was actually quite good by late 1930s standards. The 37mm gun was comparable to what the Panzer III carried initially. The armor provided reasonable protection. Reliability was better than many early German designs, which meant the tanks could actually reach the battlefield instead of breaking down during the approach march. Czech engineering had a reputation for precision, and it showed. Early campaigns in Poland and France demonstrated that these were not just adequate stopgaps. They were genuinely useful combat vehicles. But integration created immediate complications. German mechanics were not familiar with Czech components. When something broke, finding the right replacement part meant navigating a completely different supply system. Training manuals had to be translated. Ammunition specifications were slightly different, requiring careful inventory management to ensure the right shells reached the right units. What seemed like a straightforward acquisition of ready-made equipment turned into a logistical puzzle that never quite got solved completely. The bigger problem emerged over time. As combat intensified and German tank designs evolved, the Panzer 35T remained fundamentally what it had always been. There was no capacity for major upgrades. The factories in Czechoslovakia were not set up to produce improved variants on German timelines. The supply chain for parts could not easily adapt to modifications. So, while Panzer III vehicles and Panzer IV vehicles received better guns and thicker armor, the Panzer 35T stayed static, gradually falling behind the curve. It stayed static. By 1941, most Panzer 35T tanks were being withdrawn from frontline service. The math was simple. They could not survive against the newer Soviet tanks appearing on the Eastern Front. The 37mm gun was insufficient. The armor was too thin. Crews were taking casualties at rates that made continued deployment unreasonable. But this did not mean the tanks were useless. They were reassigned to secondary fronts, occupation duties, and training roles where their limitations mattered less. Many were withdrawn from the front lines. Roughly 420 were built in total, including pre-annexation Czech production. That is a substantial number, enough to equip multiple divisions in the early war period. For Germany, they represented ready-made capability that did not require diverting domestic production capacity. For a few crucial years, they filled gaps while German industry scaled up. The value was not in their long-term potential, but in their available, immediate presence. What the Panzer 35T experience taught was that captured or acquired equipment comes with hidden costs. The initial benefit is obvious: more tanks without building them yourself. But the ongoing challenges of maintenance, supply, and integration eat away at that advantage. Each foreign design requires its own parts inventory, its own training program, its own maintenance expertise. Multiply that across multiple captured systems, and the logistical burden becomes substantial. Still, in the short term, it worked. Germany got tanks when it needed them, fought battles it might not have been able to fight otherwise, and learned valuable lessons about what could and could not be effectively integrated. The Panzer 35T was not the solution to Germany's armored needs, but it was part of the solution during a period when every available resource mattered. And that distinction between permanent solutions and temporary measures was about to become even more critical. Panzer 38T, 1939. The Panzer 38T came from the same Czech factories as its predecessor, but the similarities ended there. This was a newer design, more refined, with better mechanical reliability than many German-built tanks of the same period. The suspension system handled rough terrain without constant breakdowns. The engine ran cooler and required less maintenance. Czech engineers had learned from earlier mistakes, and it showed in every aspect of the vehicle's performance. German crews noticed the difference immediately. Tanks that actually started in cold weather were a luxury not everyone enjoyed. Transmissions that did not strip gears after a few hundred kilometers meant units could maintain operational strength without constant workshop time. The 37mm gun remained the standard armament, nothing special, but the platform it was mounted on proved surprisingly durable. Early campaigns demonstrated that reliability could matter as much as firepower when maintaining momentum was critical. Production continued well past the point when the Panzer 35T had been phased out. More than 1,400 Panzer 38T tanks were built, a significant commitment to a foreign design. The decision reflected practical calculation rather than preference. German factories were busy with other projects, and the Czech facilities could produce these tanks without disrupting domestic production schedules. It was efficient, even if it meant continuing dependency on a supply chain outside direct German control. Combat effectiveness lasted longer than anyone initially expected. The 38T fought in Poland, France, and the early stages of the Eastern Front without being catastrophically outmatched. Crews developed tactics that emphasized its strengths: mobility, reliability, and the ability to operate for extended periods without breaking down. When Soviet tanks appeared that the 37mm gun could not handle, units adapted by targeting tracks and supporting equipment rather than attempting frontal penetration. But adaptation has limits. By 1942, the gap between what the Panzer 38T could do and what frontline combat required had become too wide to bridge with tactics alone. The armor was simply too thin. The gun lacked penetrating power against T-34 and K-51. Crews were being asked to fight battles where mechanical reliability did not compensate for being fundamentally outgunned. Losses mounted until the only reasonable decision was withdrawal from the most intense combat zones. What happened next revealed the tank's true value. Rather than scrapping the chassis or relegating it to occupation duties, German engineers looked at what they had: a reliable platform with good mobility and proven mechanical components. The turret was the problem, not the chassis. Remove the turret, and you had the foundation for something else entirely. The Martyr series of tank destroyers used the 38T chassis with much more powerful guns mounted in open-topped fighting compartments. The Hetzer carried a 75mm gun in a low-profile casemate design that proved remarkably effective. Suddenly, the Panzer 38T was not obsolete. It was being transformed into vehicles that could fight successfully against the latest Allied armor. The chassis that could not support a better turret could absolutely support a fixed gun installation. Production of these variants continued into 1944, long after the original tank version had disappeared from front lines. The Czech factories that had been building complete tanks now built chassis that German facilities converted into tank destroyers and assault guns. Over 2,500 chassis were eventually used for these conversions, nearly double the number of original tanks produced. The math was compelling. Why waste a proven design when you could adapt it to meet current needs? Why develop entirely new platforms when existing ones could be modified? The Panzer 38T demonstrated that obsolescence in one role did not mean uselessness overall. The key was recognizing what aspects of the design still had value and building around those strengths. What's often missed in discussions of German armor is how much the war effort depended on this kind of pragmatic adaptation. The headline weapons get attention, but the unglamorous work of keeping older designs relevant through modification and repurposing kept units equipped when new production could not meet demand. The Panzer 38T and its descendants were not glamorous, but they were present, functional, and more effective than nothing at all. And as the war ground on, that kind of practical reliability became increasingly precious. Everything changed when the 88mm gun was mounted in a rotating turret. Germany had used this gun as anti-aircraft artillery, then as an anti-tank weapon on a fixed mount. But putting it in a fully armored mobile platform created something fundamentally different. The Tiger I could engage enemy tanks at ranges where return fire was ineffective or impossible. Crews could identify targets, fire, and destroy them before opponents even knew they were under attack. The psychological impact was immediate and profound. Allied tank crews began reporting encounters where their vehicles were destroyed by something they never saw. Intelligence reports tried to make sense of the pattern: long-range kills, massive penetrating power, armor that seemed impervious to standard anti-tank weapons. When the first Tigers were captured and analyzed, the specifications confirmed what frontline units had been experiencing. It had frontal armor over 100 millimeters thick, and a gun that could penetrate equivalent armor at distances exceeding 1,500 meters. Its weight, nearly 57 tons, made it the heaviest operational tank in the world at that point. Production began in August 1942, slowly at first. The complexity of building such a massive vehicle meant factories could not simply retool overnight. Each Tiger required specialized manufacturing processes. The interleaved road wheel design, while providing excellent weight distribution, demanded precision assembly. The transmission had to handle enormous stress. Every component needed to be built to higher tolerances than standard tanks required. This was not mass production. This was careful, deliberate construction of machines that could not afford mechanical failures. Early deployments demonstrated both the potential and the problems. When Tigers fought on favorable ground with proper support, they were devastatingly effective. A single Tiger could hold a position against multiple enemy tanks, destroying them one after another, while remaining effectively immune to their fire. Crews developed well-deserved confidence. The tank felt invincible because in many situations, it genuinely was. But that confidence masked vulnerabilities that would become critical as the war progressed. Fuel consumption was staggering. The Maybach engine drank gasoline at a rate that made extended operations difficult, even when supply lines were intact. A Tiger could travel roughly 100 kilometers on a full tank under ideal conditions. Combat conditions, with constant maneuvering and periods of high engine load, cut that range significantly. Units equipped with Tigers needed dedicated fuel trucks following them constantly. When supply lines were disrupted, Tigers became immobile fortresses rather than mobile weapons. Fuel logistics defined how and when they could fight. Mechanical reliability proved inconsistent. The transmission, in particular, struggled with the tank's immense weight. Breakdowns were common enough that repair crews became essential parts of any Tiger unit. The interleaved wheels that provided such excellent cross-country performance also trapped mud and debris, which could freeze solid in winter conditions and prevent movement entirely. Crews learned to spend hours after each day's movement clearing the wheels, a maintenance burden that other tanks did not impose. Reliability was not guaranteed. Air superiority became the Tiger's greatest vulnerability. Allied aircraft learned to avoid attacking from the front where armor was thickest. Instead, they targeted engine compartments and thinner top armor. A Tiger that dominated ground combat could be destroyed by a fighter bomber it never had a chance to engage. As Allied air power grew stronger throughout 1943 and 1944, Tigers increasingly had to move only at night or in poor weather when aircraft could not operate effectively. AIR control shaped their use. Only 1,347 Tigers were built during the entire war. That's a tiny number compared to the 50,000 Shermans the United States produced, or the 60,000 T-34s the Soviets built. Each Tiger had to fight outnumbered, often severely outnumbered, which meant that tactical victories did not translate into strategic impact. A Tiger could destroy 5 or 10 enemy tanks in a single engagement, but the enemy could replace those losses, while the Tiger could not be replaced when it was eventually destroyed or abandoned due to mechanical failure. The doctrine built around the Tiger reflected this reality. They were not breakthrough weapons meant to exploit gaps in enemy lines. They were defensive assets, positioned to blunt enemy advances and inflict maximum casualties. They were psychological weapons, creating fear and caution among Allied tank crews that persisted even when Tigers were not present. But defensive success does not win wars. It delays losses. And as Germany's situation deteriorated, every Tiger that broke down or ran out of fuel represented irreplaceable combat power that simply vanished from the battlefield. The power that one individual fights could not compensate for the reality that the larger battle was being lost. Panther, 1943. Soviet T-34 tanks should not have been a surprise, but they were. When German forces encountered them in 1941, the reaction was genuine shock. Sloped armor that deflected shots. A 76mm gun that could penetrate German tanks at combat ranges. Mobility that allowed them to operate effectively on terrain that bogged down other vehicles. The T-34 forced an immediate reassessment of what a medium tank needed to be, and that reassessment became the Panther. Development happened under intense pressure. Engineers studied captured T-34 tanks, measured the armor angles, tested the suspension, and analyzed every aspect that made the Soviet tank effective. The goal was not to copy it, but to build something that incorporated its best features while avoiding its weaknesses. Sloped armor became central to the design, providing far better protection per ton of steel than vertical plates. The 75mm gun was longer and more powerful than what the Panzer IV carried, capable of engaging any Allied tank at ranges that favored the Panther. The first Panthers rolled out in January 1943, rushed into production to meet demands on the Eastern Front. Speed was prioritized over thorough testing, and that decision created immediate consequences. Early models suffered catastrophic mechanical failures. Engines caught fire. Transmissions failed after minimal use. Final drives broke under stress they should have handled easily. Panthers broke down before reaching combat, during movement to the front, sometimes even while being unloaded from trains. Crews found themselves fighting the tank as much as fighting the enemy. Temperature management was critical. The engine ran hot, and if crews did not carefully monitor gauges and manage cooling, fires were a real risk. The transmission required precise operation. Improper gear changes could damage components that were already marginal in durability. The interleaved road wheels, borrowed from Tiger design principles, had the same maintenance problems, mud and debris collection that could immobilize the tank if not constantly addressed. But when a Panther worked properly, it was extraordinary. The 75mm gun could penetrate any Allied tank from the front at ranges exceeding 2,000 meters. The sloped armor meant that even powerful enemy guns often saw their shots deflect harmlessly. Mobility was excellent for a vehicle weighing over 45 tons. A well-maintained Panther with an experienced crew was arguably the most effective tank of the entire war on a one-to-one basis. The problem was getting Panthers to the point where they worked properly. Modifications addressed the worst issues over months of production. Engine fires became less common as cooling systems were improved. Transmission reliability increased as designs were refined and manufacturing quality improved. Final drives were strengthened. By late 1943, Panthers rolling off production lines were substantially better than the initial models. But those early failures had already created a reputation problem that never fully disappeared. Production numbers reveal the commitment Germany made to this design. Nearly 6,000 Panthers were built between 1943 and 1945, making it the third most produced German tank after the Panzer IV and the Sturmgeschütz 3 assault gun. Factories worked continuously, prioritizing Panther production even as resources became scarce. The decision reflected both the tank's capabilities and the absence of better alternatives. Germany needed a medium tank that could fight T-34 tanks on equal terms, and the Panther was the only option available in meaningful numbers. Combat reports show the tension between individual effectiveness and operational reality. A single Panther could dominate an engagement, but Panthers rarely fought alone or under ideal conditions. They needed fuel, ammunition, spare parts, and trained crews, all of which were increasingly difficult to provide as Allied bombing disrupted supply chains and German industry struggled to meet demands. A mechanically perfect Panther was useless if it could not reach the battlefield, or if it had to be abandoned for lack of fuel during a retreat. What emerged was a tank that represented both the peak of German design capability and the fundamental impossibility of Germany's strategic situation. The Panther proved that German engineers could create a superior weapon when given enough time and resources. But the same conditions that made the Panther necessary, the overwhelming material superiority of Germany's enemies, meant that even superior weapons could not change the trajectory of the war. Excellence in engineering could not compensate for inadequate numbers, strained logistics, and the reality that the enemy could afford losses Germany could not. Tiger II, 1944. Armor kept getting thicker because the alternative was unacceptable. German commanders had concluded they were fighting defensively, that breakthrough operations were no longer realistic, and that every battle was about delaying the inevitable rather than changing the outcome. The Tiger II emerged from this context, a tank designed not for offensive operations, but for making every meter of ground as costly as possible for the enemy to take. The frontal armor was 180 millimeters thick and sloped, giving protection that was virtually immune to any Allied tank gun at typical combat ranges. The 88 millimeter gun was a longer, more powerful version than what the Tiger I carried, capable of destroying any enemy tank at distances where return fire was ineffective. The design aimed to create situations where the Tiger II could fight and win even when outnumbered, where superior firepower and protection compensated for inferior numbers. Weight became the defining problem. At nearly 70 tons, the Tiger II was too heavy for most bridges. Movement required careful route planning and reconnaissance to identify what infrastructure could support the tank's weight, and acceptance that certain terrain was simply impassable. Units equipped with Tiger IIs could not respond quickly to changing situations. They could not pursue retreating enemies. They could not reposition rapidly when the tactical situation demanded it. Fuel consumption made the weight problem worse. The Tiger II needed even more fuel than the original Tiger, and by 1944, Germany's fuel situation was desperate. Allied bombing had crippled synthetic fuel production. Remaining stockpiles were prioritized for aircraft and defensive operations. Tank units found themselves immobilized, not by enemy action, but by empty fuel tanks. Tigers that could have fought effectively were abandoned because moving them to new defensive positions was not possible. Only 492 Tiger IIs were built, a number that reflects both the vehicle's complexity and Germany's deteriorating industrial capacity. Production was slow, quality control was declining, and Allied bombing repeatedly disrupted manufacturing. Each Tiger II required enormous resources to build, resources that could have produced multiple Panzer IVs or Panthers. The calculation became increasingly desperate. Build fewer unstoppable tanks, or more adequate ones? Germany chose the former because the latter was no longer working. Combat deployment showed the tactical effectiveness and the strategic irrelevance of the design. Tiger IIs dominated defensive engagements when they had fuel and ammunition. Allied tank crews learned to avoid direct confrontation, instead calling in artillery or airstrikes. A Tiger II could not be defeated frontally by tank guns, but it could be destroyed by bombs, rockets, or simply bypassed while infantry dealt with its supporting forces. The tank's limitations in mobility meant it could not prevent encirclement. It could hold a position until overrun, but it could not influence battles beyond its immediate location. The psychological impact differed from the original Tiger. Allied forces respected the Tiger II's capabilities, but also understood its constraints. Intelligence reports noted that Tiger IIs were rarely found far from rail lines or major roads, and that they operated in predictable patterns because of their logistical demands. Encountering one usually meant the enemy was fighting defensively rather than offensively. The fear the original Tiger inspired had been replaced by cautious respect and tactical adaptation. Crew experiences reflected the tank's contradictions. Crews appreciated the protection and firepower, and the sense that they could engage any enemy with confidence. But they also dealt with constant anxiety about fuel, about whether they would be ordered to abandon a functioning tank because it could not be supplied, about whether mechanical problems would leave them stranded in enemy territory. The Tiger II was both the safest and most precarious tank for crews, invulnerable in combat, but desperately vulnerable to everything that happened before and after engagements. By late 1944, the strategic situation had deteriorated to the point where even perfect weapons could not change outcomes. The Tiger II exemplified this perfectly, a tank that could win every battle it fought while Germany lost the war. The gap between tactical capability and strategic reality had become unbridgeable. Building better tanks could not compensate for having fewer of them. It could not solve fuel shortages. It could not prevent Allied air supremacy. The Tiger II was a monument to what German engineering could accomplish, and a reminder that engineering alone could not determine wars. Panzer VIII, Maus, 1944. Something had gone profoundly wrong when Germany started designing a tank that weighed 188 tons. The Maus, which means mouse, represented a design philosophy detached from battlefield reality. The concept emerged from meetings where decision-makers seemed to believe that if armor was good, more armor would be better, and maximum armor would be best. Nobody asked whether a tank that could not cross most bridges had any practical use. The armor specifications were absurd. Front hull armor was 200 millimeters thick. The turret front reached 240 millimeters. This was not protection. This was a fortress that happened to have tracks. The designers mounted a 128 millimeter gun as the main armament, with a coaxial 75 millimeter gun for secondary targets. The ammunition load was limited because even the Maus's enormous internal volume could not accommodate enough shells while also fitting the crew, engine, transmission, fuel, and all the other systems necessary for operation. Only 2 prototypes were built, and even those never became fully operational. The first prototype received a turret, but remained incomplete when Soviet forces approached the testing facility. The second prototype never got past initial assembly. Engineers were still trying to solve fundamental problems that should have been obvious from the start. How do you transport something that heavy? How do you provide enough fuel for an engine that needs to move such enormous weight? How do you prevent the tank from sinking into soft ground under its own mass? The engine struggled with the demands placed on it. Even at full power, the Maus could barely reach 13 kilometers per hour on roads. Off-road performance was hypothetical at best. The ground pressure per square centimeter was lower than might be expected due to the extremely wide tracks, but that did not change the fact that crossing anything other than firm-level terrain risked getting stuck. Rivers could not be crossed using bridges. Instead, The design included a snorkel system for underwater driving, which meant the tank would sink to the riverbed and drive across the bottom. This required the following tank to provide electrical power via cable, since the engine could not run while submerged. Combat doctrine for the Mouse was never seriously developed, because nobody could figure out what to do with it. Defensive positions seemed logical, but the tank could not quickly reposition when a breakthrough occurred elsewhere. Offensive operations were impossible given the speed limitations. Supporting infantry meant keeping pace with soldiers on foot, which might have been the only tactical scenario where the Mouse's speed was not a liability. But infantry did not need a 188-ton tank for support. They needed air cover, artillery, and medium tanks that could maneuver. The resources devoted to this project were substantial, despite only 2 prototypes being built. Design work consumed engineering talent that could have improved existing tanks. Manufacturing the prototypes required specialized facilities and equipment. Testing consumed fuel that was already scarce. All of this happened while German forces were desperately short of tanks that could actually fight. The Mouse represented resource allocation that made sense only if you believed the war could still be won through technological supremacy rather than industrial capacity. When Soviet forces overran the testing facility, they found 1 Mouse with a turret and 1 without. Engineers had disabled both to prevent capture, but Soviet forces were able to combine components from both prototypes into a single functional vehicle for study. That Frankenstein Mouse was shipped to Kubinka, proving grounds where it remains today. A museum piece that never fired a shot in combat and would never have changed anything if it had. The Mouse stands as the clearest example of how far German tank design had drifted from operational reality by 1944. Every decision that led to its creation reflected priorities disconnected from what actually determined battlefield success. Armor thickness mattered, but mobility, reliability, and availability mattered more. Firepower was valuable, but not if the platform carrying the gun could not reach combat zones. Protection kept crews alive, but only if the vehicle could participate in battles to begin with. The Mouse failed every practical test, while succeeding at theoretical metrics that had ceased to matter. And that failure, more than any single defeat, illustrated how completely the war had already been lost. Germany's tanks told a story that went far beyond steel and gunpowder. They began with training vehicles forced into real combat, evolved into workhorses that carried impossible burdens, and ended with fortresses too heavy to move. Each design reflected the moment it was born into. Early pragmatism gave way to desperate innovation, which collapsed into engineering ambition, completely severed from reality. The progression from Panzer I into Mouse was not just about building better tanks. It was about a nation that started a war it could not finish, kept fighting battles it could not win, and eventually built weapons for a conflict that existed only in the minds of those who refused to see what was already lost. The tanks did not fail Germany. Germany failed the tanks by asking them to accomplish what no amount of armor or firepower could ever achieve.